There's something profoundly humbling about looking up at the night sky and realizing just how small we are in the grand tapestry of the cosmos. But what if I told you that beyond those twinkling stars lie landscapes so extraordinary, so utterly mind-bending, that they challenge everything we think we know about reality? Picture a place where clouds of gas glow like celestial watercolors, where stars are born in violent, beautiful chaos, and where entire galaxies collide in a dance that spans millions of years. These aren't just distant specks of light, they're cosmic masterpieces, each one a testament to the universe's boundless creativity and power. Today, we're setting off on a journey to explore 22 of the most awe-inspiring sights the universe has to offer. From the fiery tendrils of nebulae to the eerie silence of supermassive black holes, these are the places where science and imagination collide. Some of these cosmic landscapes are so vast they could swallow our solar system without a second thought, while others are so delicate they seem like they'd vanish with a single breath. Yet each one holds clues to the mysteries of existence: how stars are born, how galaxies evolve, and perhaps even how life itself began. This isn't just a tour of pretty space pictures. It's an invitation to see the universe differently, to step outside the confines of our tiny planet and witness the grandeur of creation itself. By the time we're done, you'll never look at the night sky the same way again. So take a deep breath, open your mind to the impossible, and let's dive into the wonders that await us among the stars. The cosmos is calling, and what you're about to see will leave you speechless. The pillars of creation stand like ancient sentinels in the vast expanse of the Eagle Nebula, their towering forms sculpted by the very forces that give birth to stars. These colossal structures, stretching over 5 light-years tall, are more than just a breathtaking cosmic photograph. They're a window into the violent, creative process that shapes our universe. Imagine clouds of gas and dust so dense they blot out the light behind them, yet so delicate that the radiation from nearby stars is slowly tearing them apart. Within these pillars, gravity works its magic, pulling matter together until the pressure ignites new suns, lighting up the darkness with pockets of newborn starlight. What makes this landscape truly extraordinary isn't just its scale or beauty, it's the fleeting nature of the spectacle. The Hubble telescope's iconic image captures a moment in time, a snapshot of structures that may already be vanishing. The same stellar winds carving these pillars into eerie, twisted shapes will one day erode them completely, scattering their material across the cosmos. Yet even as they fade, they leave behind a legacy, the stars they helped create. Some of those stars might someday host planets, and perhaps even life, making the pillars of creation a cosmic cradle in the truest sense. And then there's the artistry, the way these clouds seem to twist and curl like smoke frozen in time. Their shapes evoke everything from dragon's claws to celestial temples, proving that nature doesn't need fiction to inspire awe. But beyond their beauty lies a deeper mystery. Hidden within the dust are pockets of cold gas so dense they resist the destructive forces around them, shielding fledgling stars like cosmic incubators. Scientists are still unraveling how these delicate balance of creation and destruction plays out, making the pillars of creation not just a sight to behold, but a puzzle to solve. This is more than a distant wonder. It's a reminder that the universe is alive with change. The same forces that built these pillars will one day dismantle them, only to recycle their materials into something new. In that cycle, we find a profound truth: destruction and creation are two sides of the same cosmic coin, and even the grandest structures are just temporary brushstrokes in an ever-evolving masterpiece. If the pillars of creation show us the gentle birth of stars, the Crab Nebula reveals their spectacular death and the stunning aftermath that follows. This swirling cloud of gas and dust is what remains of a massive star that tore itself apart in a supernova explosion so bright it was visible in broad daylight nearly 1,000 years ago. Today, those expanding debris fields stretch over 10 light-years across, glowing with an eerie blue-white light as energized particles race through them at nearly the speed of light. At its heart lies one of the most fascinating objects in the cosmos, a pulsar spinning 30 times every second, shooting out beams of radiation like a cosmic lighthouse. What makes the Crab Nebula so mesmerizing isn't just its violent past, but the way it continues to evolve right before our eyes. The filaments of gas twist and ripple in real time, changing shape over mere decades as they expand outward into space. Some regions glow in vivid reds from hydrogen emissions, while others shimmer in blue from the intense radiation of the pulsar. It's a celestial graveyard, yes, but also a recycling plant on the grandest scale. Every atom flung outward in that ancient explosion will one day be gathered back together by gravity, forming the building blocks of new stars, planets, and perhaps even life. And then there's the sheer energy. The pulsar at the nebula's core packs the mass of our sun into a sphere no bigger than a city, yet it generates enough power to light up the entire nebula like a neon sign. That energy doesn't just create light, it challenges our understanding of physics itself, accelerating particles to energies we still can't reproduce on Earth. Scientists study this cosmic powerhouse to unlock secrets about magnetic fields, extreme matter, and the very nature of space-time. But perhaps the most humbling thought is this: we're witnessing a process that plays out across the universe, yet we caught it at the perfect moment. The Crab Nebula is young by cosmic standards, still vibrant and dynamic, giving us a front-row seat to the aftermath of stellar death. In a few thousand years, those glowing filaments will fade, dispersing into the void. But for now, they blaze as a reminder that even in destruction, the universe creates something breathtaking. Einstein's cross is one of the universe's most elegant illusions, a cosmic magic trick where light bends and splits before our eyes. Nearly 9 billion light-years away, a brilliant quasar, a beacon of intense radiation powered by a supermassive black hole, shines with the brightness of 1,000 galaxies. But between us and that distant light lies another galaxy, its immense gravity warping space-time like a lens. Instead of seeing one quasar, we see four perfect copies arranged in a cross, each a distorted, stretched-out version of the original. This isn't just a mirage, it's proof that space itself can twist and magnify light, reshaping our view of the cosmos. What makes this phenomenon so extraordinary isn't just its rarity, but what it tells us about the fabric of reality. Gravitational lensing, as predicted by Einstein's theory of relativity, shows that massive objects don't just pull on matter, they bend the very space around them. The foreground galaxy in Einstein's cross acts like a funhouse mirror, distorting the quasar's light into multiple paths that travel different distances before reaching us. By studying the subtle delays between these images, astronomers can measure the universe's expansion rate with astonishing precision, offering clues to the nature of dark energy and the fate of the cosmos. But the real wonder lies in the details. The four images aren't identical. Some appear brighter, others slightly stretched, depending on how the light warps around the galaxy's uneven mass. This asymmetry reveals secrets about the lensing galaxy's structure, including hidden pockets of dark matter, the invisible scaffolding that shapes the universe. Without this cosmic lens, the quasar would be too faint to study in such detail. thanks to gravity's sleight of hand, we get a magnified glimpse into the distant universe, like peering through a keyhole at the dawn of time. And then there's the poetry of it all. Light that left the quasar when the universe was barely a third of its current age has traveled across eons, only to be reshaped by a chance alignment before finally reaching our telescopes. It's a reminder that the cosmos is full of surprises, places where the rules of perspective break down, and where the universe itself becomes the artist, painting illusions on the grandest canvas imaginable. Einstein's cross isn't just a scientific tool, it's a testament to the fact that even in the vastness of space, beauty and discovery are often hidden in the twist of a cosmic lens. Now imagine a place where stars move in frenzied orbits, whipping around an unseen center at unimaginable speeds, a place where the fabric of space is so warped that not even light can escape. This is the realm of the supermassive black hole, and at the heart of our own galaxy, there's one lurking in the shadows, its presence betrayed only by the frantic dance of the stars around it. At the very center of our galaxy, hidden behind thick clouds of interstellar dust, lies a monster, Sagittarius, a star, a supermassive black hole with a mass 4 million times greater than our Sun. Though we can't see it directly, the clues are undeniable. Stars race around this invisible titan at thousands of kilometers per second, their orbits tracing tight, looping paths that betray the presence of something unimaginably dense and powerful. One star, known as S2, completes its breakneck journey in just 16 years, a cosmic sprint that would take our solar system 230 million years to match. What makes this black hole so fascinating isn't just its size, but how it shapes everything around it. Like an invisible puppeteer, its gravity tugs on nearby gas clouds, stretching them into spiraling ribbons that glow with X-rays as they're torn apart. Some of this material vanishes past the event horizon, the point of no return, while the rest gets slingshotted away at nearly the speed of light in fiery jets. These outbursts ripple through the galaxy, influencing star formation thousands of light years away. And then there's the groundbreaking image, the first ever glimpse of Sagittarius, a star's shadow, captured by the Event Horizon Telescope. That eerie, glowing ring isn't the black hole itself, but light bending around it in a perfect circle of cosmic distortion. The dark center, that's the event horizon, where gravity becomes so strong that not even light can escape. It's a confirmation of Einstein's predictions, but also a mystery. Why is this black hole so quiet compared to the raging behemoths in other galaxies? But the real question is, what happens if you get too close, cross the event horizon, and time itself would stretch and slow from an outside observer's perspective, while for you, the pull of tidal forces would become inescapable? Spaghettification, as scientists grimly call it, would stretch every atom in your body into a thin, cosmic noodle long before you reach the singularity. Yet despite its destructive power, Sagittarius, a star, isn't a threat, it's a cosmic architect. Without its gravitational anchor, the Milky Way as we know it might not even exist. This hidden giant reminds us that sometimes the most powerful forces in the universe are the ones we can't see. It's a silent guardian, a destroyer, and a creator all at once. Proof that even in the darkest corners of space, there's beauty in the chaos. Stretching across space like a colossal celestial eye, the Helix Nebula stares back at us with haunting beauty, a dying star's final act of cosmic artistry. Known as the Eye of God for its uncanny resemblance to a human iris, this planetary nebula is the aftermath of a sun-like star shedding its outer layers in a slow, radiant farewell. The intricate rings of glowing gas spanning nearly 3 light-years ripple outward in delicate blues and reds, illuminated by the ultraviolet fury of the tiny white dwarf at its core. This isn't just a spectacle, it's a preview of our own sun's destiny 5 billion years from now, when it too will exhale its atmosphere into the void. What makes the helix so mesmerizing isn't just its symmetry, but the chaos hidden within. Those ethereal rings are actually bubbles of gas, sculpted by stellar winds and radiation into shapes that defy simple explanation. Some filaments twist like DNA strands, while others form comet-like knots, each one a cosmic puzzle. These structures, dubbed cometary globules, are dense pockets of material resisting evaporation, their tails streaming away from the central star like smoke in a cosmic breeze. Scientists study these details like forensic detectives, piecing together the final moments of a star's life, and discovering that even in death, there's staggering complexity. And then there's the scale. Though it appears tranquil from afar, the helix is a maelstrom of motion. The outer gases race outward at tens of thousands of kilometers per hour, while the inner regions churn with turbulence, creating shocks and ripples that glow in eerie hues. Infrared observations reveal hidden rings of dust, invisible to the human eye, stretching far beyond the visible glow remnants of earlier eruptions, like layers of a cosmic onion. This layered structure tells a story not of a single cataclysm, but of a star's slow unraveling over millennia, puffing away its soul in stages. But perhaps the most profound lesson the helix offers is one of connection. Every atom in those expanding rings, carbon, oxygen, nitrogen, was forged in the star's nuclear furnace. These elements, now drifting into interstellar space, will one day become part of new stars, planets, and possibly even life. The helix isn't just an end, it's a beginning, a reminder that in the grand cycle of the cosmos, death feeds creation, and every farewell plants the seeds of something new. Now, shift your gaze to a place where invisible forces paint the sky in strokes of radiant energy, a realm where magnetism itself becomes an artist. The next wonder we'll explore doesn't just defy imagination, it bends the very rules of physics. The Vale Nebula drifts through space like a ghostly tapestry, its delicate filaments glowing in electric blues and fiery oranges, the remnants of a star that died in a cataclysm so powerful its light reached Earth over 5,000 years ago. This sprawling supernova remnant, stretching nearly 110 light-years across, isn't just debris, it's a cosmic fossil, preserving the final moments of a massive star's explosive death. Unlike the slow, poetic unraveling of the Helix Nebula, the Vale was born in violence, its intricate lace-like structures forged by shock waves traveling at millions of kilometers per hour, heating the surrounding gas until it fluoresces like a neon sign in the void. What makes the Vale so astonishing isn't just its beauty, but its resilience. Those delicate threads of ionized gas, some no thicker than our solar system, have survived for millennia despite the chaos around them. The secret lies in their structure, dense knots and braided filaments that resist dissipation, held together by magnetic fields as invisible as they are powerful. Like cosmic spider silk, these strands endure, their vibrant colors revealing the presence of oxygen, sulfur, and hydrogen elements cooked in the star's core and blasted into space, now glowing like celestial stained glass. Zoom in closer, and the nebula reveals even more mysteries. The shock waves responsible for its glow are still propagating outward, colliding with interstellar material and creating ripples of turbulence. In some regions, the gas forms bubble-like structures, while in others, it stretches into eerie, elongated tendrils. This isn't a static relic, it's a dynamic landscape, still evolving from the force of that ancient explosion. Astronomers compare studying the Vale to watching a slow-motion firework, where every twist and knot tells a story about the star's final moments and the physics of interstellar destruction. But perhaps the most profound revelation lies in what the veil leaves behind. Scattered within its filaments are the raw ingredients for new stars and planets, heavy elements like iron, silicon, and magnesium, forged in the star's death throes. These atoms will eventually mix with interstellar clouds, enriching future generations of cosmic objects. The veil isn't just a tombstone, it's a nursery, proving that even the most destructive events in the universe are part of a grand cyclical rebirth. Now, shift your gaze to a phenomenon where gravity doesn't just bend light, it shatters it into fragments, creating a celestial kaleidoscope. The next cosmic wonder we'll explore isn't just a single object, but a fragmented mirage, a glimpse into the universe's most deceptive depth. The Orion Nebula isn't just another patch of light in the night sky, it's a cosmic incubator, a place where stars are born in such abundance that its glow pierces through space, visible even without a telescope. Nestled in Orion's sword, this sprawling stellar nursery spans 24 light-years, its turbulent clouds of gas and dust swirling in a dance of creation and destruction. At its heart lies the trapezium cluster, 4 blazing young stars so intense their radiation carves cavities in the surrounding gas, illuminating the nebula like a celestial spotlight. But the real magic happens in the shadows hidden within those dark, dusty folds. Hundreds of protostars flicker to life, each one a potential solar system in the making. What sets the Orion Nebula apart isn't just its visibility, but the sheer chaos of its environment. Temperatures here swing from extremes. Some regions hover just above absolute zero, while others, bombarded by ultraviolet light from massive stars, heat up to thousands of degrees. This thermal roller coaster triggers chemical reactions, forging complex molecules like water, carbon monoxide, and even organic compounds. In the densest pockets, gravity overpowers the turbulence, collapsing gas into spinning disks that will eventually birth planets. We're witnessing the same processes that, 4.5 billion years ago, gave rise to our own Sun and Earth. Then there's the artistry. Hubble's images reveal pillars and ridges sculpted by stellar winds, their surfaces bubbling with evaporating gaseous globules, tiny cocoons where fledgling stars resist being stripped bare by radiation. Some of these structures resemble earthly landscapes, earning names like the Great Wall or the Whispering Gallery, as if the cosmos itself is echoing familiar shapes. But the most awe-inspiring detail, the nebula's light takes over 1,300 years to reach us, meaning we're seeing it not as it is today, but as it appeared when the Vikings were raiding Europe. Scientists treasure Orion as a live-action textbook on star formation. By studying its protoplanetary disks, they've spotted gaps and rings, telltale signs of planets coalescing. Some young stars here shoot out jets of material at supersonic speeds, while others flicker unpredictably as they devour gas from their surroundings. This isn't a serene nursery, it's a riotous kindergarten where stellar toddlers jostle for space, their tantrums shaping the nebula's ever-changing face. Yet for all its violence, the Orion Nebula offers a profound message. Destruction fuels creation. The same radiation that tears apart nearby clouds also compresses them, triggering new rounds of star birth. Every atom here, whether forged in the Big Bang or cooked inside ancient stars, is part of an endless cycle, one that might someday seed life elsewhere in the galaxy. So the next time you spot Orion's faint glow, remember, you're not just looking at a pretty cosmic cloud, you're glimpsing the factory where worlds are born. Now brace yourself for a place where the laws of physics seem to unravel, a cosmic maelstrom where temperatures don't just rise, they shatter every conceivable limit. The next landscape we'll explore doesn't just defy imagination, it redefines the very meaning of extreme. The Boomerang Nebula defies logic, a place so cold it makes the void of space seem warm by comparison. At just 1 degree above absolute zero, this cosmic freezer holds the record as the coldest known natural environment in the universe. But how does a nebula, born from a dying star, become colder than the afterglow of the Big Bang itself? The answer lies in its unique death throes. Unlike most stars that shed their outer layers gently, the Boomerang's progenitor ejected its atmosphere at breakneck speeds, nearly 600,000 kilometers per hour, expanding so rapidly that the gas cooled to temperatures lower than anything nature typically produces. What makes this nebula mesmerizing isn't just its chill, but its haunting symmetry. Twin lobes of ultra-cold gas stretch outward like a cosmic bow tie, their delicate curves sculpted by stellar winds and magnetic fields. These lobes aren't static, they're racing into space, carrying away heat like an interstellar refrigerator. Meanwhile, the central star, now a faint white dwarf, pumps out just enough energy to illuminate the expanding gas without warming it, creating a paradox, a glowing object colder than the darkness around it. Telescopes reveal intricate ripples within the lobes, frozen shock waves that tell the story of the star's violent gas loss over thousands of years. But the real mystery lies in the physics. Absolute zero, the temperature where all molecular motion stops, is impossible to reach naturally. Yet the Boomerang Nebula flirts with that limit, thanks to a phenomenon called adiabatic cooling. As the gas expands into the vacuum of space, it does work against its own pressure, bleeding energy until it nears the coldest possible temperature. Scientists study this process like a cosmic lab experiment, probing how matter behaves under conditions we can't replicate on Earth. And then there's the irony. This frigid nebula began as a scorching stellar core. In its final act, the star didn't go out with a bang, but with a whisper, a gasp of gas so vast and thin that it became a celestial deep freeze. Hidden in that cold lies a clue to how stars recycle themselves. The same molecules now drifting at near absolute zero will one day mix with interstellar clouds, seeding future stars and planets. The Boomerang Nebula isn't just a curiosity. It's a reminder that even in death, stars sculpt the universe in ways we're only beginning to understand. Now shift your gaze from the coldest reaches to a place where temperatures soar beyond comprehension, a celestial forge where the universe bends matter to its will. The next cosmic spectacle doesn't just push boundaries, it obliterates them. The Carina Nebula is a cosmic masterpiece of chaos and creation, a sprawling stellar nursery where the forces of light and gravity wage an endless battle. Stretching over 300 light-years across, this turbulent sea of gas and dust glows with the intensity of 1,000 suns, its vivid hues painting the cosmos in shades of crimson, gold, and electric blue. Towering pillars, some twice the height of our solar system, rise like ancient skyscrapers, their surfaces etched by the relentless winds of newborn stars. But the true heart of this maelstrom lies in its most infamous resident, Eta Carinae, a hypergiant star so unstable it makes supernova look predictable. This star is a ticking time bomb. With a mass over 100 times that of our Sun, Eta Carinae burns through its fuel at a staggering rate, periodically erupting in outbursts that eject entire solar masses of material into space. In the 1800s, it briefly became the second brightest star in the night sky during one such eruption, a cosmic tantrum that left behind the homunculus nebula, a bipolar cloud of debris expanding at millions of kilometers per hour. Today, telescopes reveal intricate dust lanes and shock waves rippling through this structure, evidence of a star teetering on the edge of self-destruction. One day, perhaps tomorrow or in 1,000 years, Eta Carinae will explode in a supernova so bright it could outshine the moon, Yet even amid this violence, the Carina Nebula thrives. The same radiation that tears apart gas clouds also compresses them, triggering waves of star formation. Within the nebula's darkest crevices, protostars flicker to life, their spinning disks of dust already hinting at future planets. Some regions, like the aptly named Mystic Mountain, showcase the nebula's duality, delicate tendrils of gas clinging to dense pillars, backlit by the glare of massive young stars. These structures are ephemeral, slowly evaporating under the stellar onslaught, yet within them, new solar systems take shape. What makes Carina truly extraordinary isn't just its scale or beauty, but its role as a cosmic laboratory. Here, astronomers study how massive stars influence their environments, how shock waves trigger chemical reactions, and how the raw materials for life disperse into the galaxy. Every element heavier than hydrogen, the oxygen in your lungs, the calcium in your bones, was forged in places like this, then scattered across space by stellar winds and explosions. The Carina Nebula isn't just a spectacle, it's a reminder that creation is born from chaos, and even the most violent corners of the universe hold the seeds of something new. Now prepare to journey to a place where the laws of physics stretch to their breaking point, a realm where gravity doesn't just bend time, but twists it into knots. The next cosmic wonder we'll explore doesn't just challenge our imagination, it defies the very fabric of reality. At the edge of a black hole, reality unravels. The event horizon isn't just a boundary, it's the ultimate point of no return, where gravity's pull becomes so overpowering that not even light can escape. Picture standing on the shore of a cosmic waterfall, where the river of space itself plunges inward at impossible speeds. The recent images of the supermassive black hole at the heart of Galaxy M87 gave us our first glimpse of this phenomenon. A fiery ring of light warped by gravity into a perfect circle, framing the abyss at its center. That glow isn't the black hole itself, but photons trapped in a death spiral, orbiting at the brink before vanishing forever. What makes the event horizon so terrifying isn't just its power, but the way it distorts time and space. Cross this invisible threshold, and the universe as you know it ceases to exist. The gravitational forces here are so extreme they'd stretch you into a thread of atoms, a process scientists grimly call spaghettification. Your feet, pulled faster than your head, would elongate like taffy until you were nothing more than a stream of particles spiraling toward the singularity. But here's the cruel twist. To an outside observer, you'd appear frozen in time, forever suspended at the edge, your last moments stretched into eternity. Yet the event horizon isn't just a destroyer, it's a cosmic laboratory. The glowing ring in the M87 image reveals secrets about how black holes spin, how they consume matter, and how they warp the fabric of spacetime itself. The asymmetry in its brightness hints at a maelstrom of motion, with one side brighter as superheated gas races toward us at near light speed. Scientists pore over these details like detectives, decoding the physics of the universe's most extreme environments. And then there's the ultimate mystery: what lies beyond? General relativity predicts a singularity, a point of infinite density where the laws of physics break down. But some theories suggest wormholes, alternate universes, or even gateways to other dimensions. The truth is, we don't know. The event horizon isn't just a barrier to matter, it's a curtain shielding the greatest puzzles in cosmology. This is where science meets the sublime. A black hole's edge is more than a gravitational trap. It's a reminder of how little we understand about the universe. It challenges our theories, fuels our imagination, and proves that sometimes the most profound truths lie just beyond our reach, hidden in the dark heart of the unknown. Now, shift your gaze from the abyss to a phenomenon where light doesn't vanish, it multiplies. The next cosmic wonder we'll explore doesn't just bend the rules, it shatters them, creating not one image but many. The Large Magellanic Cloud floats through space like a ghostly ship adrift in the Milky Way's gravitational wake, a satellite galaxy so close we can see its star clusters with the naked eye from the southern hemisphere. But don't let its dwarf galaxy label fool you. This cosmic neighbor is a powerhouse of stellar activity, a place where the raw chaos of the early universe still plays out in vivid detail. Stretching across 14,000 light-years, it's a mosaic of blazing star clusters, swirling gas clouds, and supernova remnants, each telling a different chapter of galactic evolution. And at its heart lies the crown jewel, the Tarantula Nebula, a stellar factory so prolific it outshines every star-forming region in our own galaxy. What makes the Tarantula Nebula extraordinary isn't just its size, it's the sheer intensity of its stellar production line. Imagine a cloud of gas over 600 light-years wide, glowing so brightly that if it were as close to us as the Orion Nebula, it would cast shadows on Earth. Within its turbulent depths, massive stars ignite in rapid succession, their ultraviolet radiation carving vast cavities in the surrounding gas while triggering new waves of star birth. One cluster alone, R136, contains some of the most massive stars ever discovered, celestial titans weighing over 200 times the mass of our Sun, burning so fiercely they live fast and die young, exploding as supernova within a few million years. But the real magic happens in the nebula's delicate balance of creation and destruction. The same stellar winds that shred gas clouds also compress them, squeezing pockets of hydrogen until they collapse into new stars. Some regions resemble cosmic spiderwebs, filaments of dust threaded with newborn stars, their light slowly evaporating the very material that birthed them. This constant tug of war makes the tarantula a living laboratory for understanding how the first galaxies lit up the early universe. Unlike the Milky Way, where star formation is more subdued, the Large Magellanic Cloud's lower gravity and metal-poor gas mimic conditions from billions of years ago, offering a rare glimpse into the cosmic past. And then there are the surprises. In 1987, a star in the Large Magellanic Cloud went supernova, its light reaching Earth as the brightest stellar explosion seen in 4 centuries. Supernova 1987 became a Rosetta Stone for astronomers, revealing how dying stars scatter heavy elements into space. Today, its expanding shockwave continues to collide with pre-existing gas, creating glowing rings that evolve year by year, a real-time lesson in how stellar death seed future generations of stars and planets. Yet for all its ferocity, the Large Magellanic Cloud is ephemeral. Gravity's relentless pull is slowly tearing it apart, stretching its stars into a streaming arc around the Milky Way. In a few billion years, it may be completely absorbed, its identity lost to our galaxy's hunger. But for now, it blazes as a reminder that even the smallest galaxies can hold the most dazzling secrets, a fireworks display of cosmic proportions, lighting up our celestial backyard. Now shift your gaze to a structure so vast it defies comprehension. A whirlpool of galaxies locked in a dance that spans hundreds of millions of light years. The next cosmic wonder we'll explore isn't just a single object. It's a gravitational masterpiece, a testament to the invisible threads that weave the universe together. The Whirlpool Galaxy spins through space like a celestial ballerina, its spiral arms tracing graceful arcs across the void, a masterpiece of galactic choreography. Officially known as M51, this stunning structure isn't dancing alone. It's locked in a gravitational embrace with a smaller companion galaxy, NGC 5195, their mutual pull stretching streams of stars and gas into a cosmic bridge between them. What makes this pair so mesmerizing isn't just their beauty, but the story they tell about how galaxies grow. Those vibrant pink knots along the Whirlpool's arms. They're stellar nurseries ignited by the gravitational tug of war between the two galaxies, compressing gas clouds until they burst into newborn stars. This isn't destruction, it's creation on a galactic scale. Zoom in closer, and the Whirlpool reveals even more secrets. The smaller galaxy's gravity has twisted one of the Whirlpool's spiral arms into a distorted, feathery plume, a testament to the sheer force of their interaction. Yet despite this chaos, the Whirlpool's core remains remarkably orderly, a glowing hub of older stars, its supermassive black hole quietly anchoring the maelstrom. This contrast between the serene center and the turbulent arms offers a snapshot of galactic evolution in action. Over millions of years, the two galaxies will continue their slow dance, eventually merging into a single, larger galaxy, a fate that awaits our own Milky Way when it collides with Andromeda billions of years from now. But the real lesson here lies in the details. The Whirlpool's star-forming regions are younger and more abundant than those in isolated galaxies, proving that collisions aren't just crashes, they're catalysts. The same gravitational forces that warp galactic shapes also compress gas, triggering starbursts that light up the cosmos. Telescopes have even spotted tidal dwarf galaxies, forming in the stretched-out streams between the two entire new galactic fragments born from the wreckage of their interaction. It's a reminder that in the universe, endings often disguise new beginnings. Now, shift your gaze to a paradox written in starlight, a place where the inhabitants seem older than the stage on which they perform. The next cosmic wonder we'll explore doesn't just challenge our understanding of time. It rewrites the very timeline of the universe. Deep in the Milky Way's halo, a solitary star flickers with secrets older than time itself, the Methuselah star, officially known as HD 140283. This ancient stellar relic defied logic when initial measurements suggested it was 16 billion years old, a number that sent shockwaves through the scientific community. How could a star predate the universe, which current estimates place at 13.8 billion years? The paradox wasn't just a glitch, it was a cosmic wake-up call, forcing astronomers to re-examine everything from stellar physics to the very timeline of existence. What makes this unassuming yellow star so extraordinary isn't just its age, but what it reveals about the infancy of the cosmos. Unlike most stars in our galaxy, Methuselah is a population 2 star, a metal-poor relic from an era when the universe was still forging its first heavy elements. Its composition reads like a fossil record, trace amounts of iron, barely 1/200th of what's found in our sun, hinting at a birth before supernova had seeded space with heavier materials. Yet pinning down its exact age required untangling a web of variables: its brightness, distance, nuclear fusion rates, even the expansion history of the universe itself. Revised calculations now place Methuselah at 14.5 billion years, still breathtakingly old but just within the universe's lifespan, the key adjustment. Accounting for how gravity warps time near dense objects, as the star orbits through the galaxy's halo, it's dipped in and out of intense gravitational fields, subtly slowing its clock relative to ours. Those microseconds add up over billions of years, like a cosmic time dilation correction, but the implications stretch far beyond one star. Methuselah's longevity suggests the first stars may have formed earlier than we thought, perhaps within 100 million years of the Big Bang, rewriting the narrative of cosmic dawn. Then there's the star's silent testimony about stellar evolution. Most stars its size would have burned out eons ago, but Methuselah's frugal fuel consumption, burning hydrogen slower due to its low metal content, granted it an improbable lifespan. It's a living time capsule, its light carrying fingerprints from an era when galaxies were just beginning to coalesce. Every photon reaching our telescopes has traveled nearly as long as existence itself, offering a glimpse into conditions we can only simulate in supercomputers. Now shift your gaze from the ancient to the absurd, a world where the skies rain diamonds. The next cosmic wonder we'll explore isn't just a poetic fantasy. It's a place where atmospheric chemistry bends reality into something stranger than fiction. Neptune's atmosphere hides a spectacle straight out of science fiction, a storm of diamonds. At depths where pressures exceed 1 million times Earth's surface, methane molecules shatter under the crushing weight, releasing carbon atoms that are squeezed into crystalline perfection. These aren't tiny gemstones. Some models suggest they could grow as large as icebergs, plunging through slushy layers of compressed hydrocarbons like glittering hail. But the real marvel lies even deeper, where temperatures soar to thousands of degrees and pressures defy comprehension. Here, scientists theorize, lies an ocean unlike any other, a vast sea of liquid diamond, its surface churned by diamond icebergs buoyed on carbon waves. What makes this phenomenon so extraordinary isn't just the alien luxury of it all, but how it reshapes our understanding of planetary interiors. On Neptune, weather isn't about water cycles, but carbon choreography. Lightning bolts rip through methane-rich skies, forging more carbon feedstock for the diamond factories below. The gems themselves may sink until they reach the planet's rocky core, accumulating in layers so thick they could rival Earth's crust in mass. Some theories even suggest these diamonds act like thermal conductors, ferrying heat from the planet's interior and shaping its violent wind patterns, winds that howl at over 2,000 kilometers per hour, the fastest in the solar system. Yet Neptune isn't alone in its exotic weather. Across the cosmos, atmospheres defy earthly logic. On Venus, sulfuric acid rains from metal-clouded skies only to evaporate before hitting the ground. Brown dwarfs, failed stars hovering between planets and stars, host storms of molten iron and silicate clouds that condense like fog. Even in our solar system's backyard, Saturn's moon Titan boasts methane monsoons that carve river valleys into icy plains, while Jupiter's Great Red Spot rages with ammonia cyclones larger than continents. The lesson, diamond rain, isn't just a curiosity, it's a window into the infinite creativity of planetary physics. Where we see impossibility, the universe sees another Tuesday. These alien meteorologies prove that the building blocks of reality can assemble in ways that humble our imagination, turning even the most far-fetched fantasies into scientific fact. And somewhere beneath Neptune's blue haze, a glittering downpour continues, a reminder that the cosmos is richer, stranger, and more wondrous than we dare to dream. Now turn your gaze to a phenomenon where light doesn't just travel, it dances. The next cosmic wonder we'll explore bends the very fabric of perception, creating illusions so perfect they fool even the sharpest telescopes. The Sombrero Galaxy spins through the void like a celestial hat tossed into space, its wide brim of dark dust lanes contrasting sharply against the glowing central bulge. Officially catalogued as M104, this edge-on spiral galaxy presents one of the most iconic silhouettes in the cosmos, a perfect demonstration of nature's ability to blend artistry with violent history. Those Inkai dust rings aren't just decorative, they're cosmic crime scenes, evidence of a turbulent past where the Sombrero likely devoured smaller galaxies, absorbing their stars and stretching their remains into those dramatic dark bands we see today. Peer closer and the galaxy reveals even more secrets. That brilliant central bulge, it's packed with ancient stars, so densely concentrated that their collective glow outshines most other spiral galaxies. But buried within that golden haze lies something unexpected, a supermassive black hole roughly 1 billion times the mass of our Sun, one of the largest ever detected. This hidden giant whips the surrounding stars into frenzied orbits, their motion betraying its presence like shadows around an invisible flame. The Sombrero's core is a study in extremes, tranquil in appearance, yet seething with gravitational fury just beneath the surface. What truly sets this galaxy apart is its hybrid nature. Unlike most spirals with their flat, pancake-like disks, the Sombrero displays characteristics of both spiral and elliptical galaxies, a cosmic chimera that's left astronomers puzzled. Some theorize its unique shape resulted from a long-ago collision where another galaxy plunged straight through its center, scattering stars vertically like a stone disturbing a pond. This would explain the unusually thick disk and the swarm of globular clusters, over 2,000 of them, orbiting the galaxy like bees around a hive. For comparison, our Milky Way has barely 150. Then there's the infrared surprise. When viewed in wavelengths invisible to human eyes, the Sombrero's dust rings blaze with the heat of newborn stars, hidden from optical telescopes by their dusty cradles. This hidden stellar nursery suggests the galaxy isn't just a relic of past violence, it's still quietly crafting new suns even as its central black hole looms over them. It's a portrait of cosmic balance where creation and destruction coexist in a delicate dance. Perhaps the most mesmerizing detail is how this galaxy freezes a moment in time. The precise alignment of its edge-on orientation lets us study structures that would otherwise remain hidden. The thickness of its disk, the distribution of its dust, even the faint halo of dark matter that extends far beyond its visible light. In the Sombrero, we don't just see a galaxy, we see the entire life cycle of galactic evolution written in starlight, from its cannibalistic youth to its stately middle age. A reminder that even the most serene cosmic vistas often hide the most dramatic stories. SN 1987 wasn't just another exploding star, it was a cosmic Rosetta Stone rewriting the textbook on stellar death. When its light reached Earth on February 23, 1987, astronomers witnessed something unprecedented, the final moments of a blue supergiant star in the Large Magellanic Cloud, a celestial neighbor just 160,000 light-years away. For the first time in modern history, scientists had a front-row seat to a supernova close enough to study in exquisite detail. From the initial flash of neutrinos that raced ahead of the visible explosion to the expanding debris field that continues to evolve decades later. What makes this stellar catastrophe so extraordinary isn't just its brightness, though at its peak, it outshone every star in its galaxy, but the intricate aftermath. Hubble's images reveal a string of pearls, glowing rings of gas lit up by the explosion's shockwave as it plows through material ejected by the doomed star thousands of years earlier. These rings aren't static, they're a time lapse of stellar mortality, with new hotspots flaring up as the shockwave collides with denser pockets of gas. One particularly bright knot, dubbed Spot 1, shines with the intensity of 100 suns, a testament to the sheer energy still rippling outward from the blast. But the real revolution came from what we couldn't see. 3 hours before the visible light arrived, underground detectors captured a burst of neutrinos, ghostly particles that slip through matter like shadows through a wall. This confirmed a long-held theory that collapsing stars emit 99% of their energy in these invisible particles, a silent scream preceding the visual fireworks. For astrophysicists, it was like discovering a hidden chapter in the story of stellar death, one written in a language far subtler than light. Decades later, SN 1987 keeps giving. The expanding debris has begun slamming into the inner ring at 60 million kilometers per hour, heating gas to millions of degrees and creating X-ray emissions that telescopes monitor like cosmic vital signs. Meanwhile, the collapsed core, now a neutron star just 20 kilometers wide but weighing 500,000 Earth, should theoretically be visible, yet it remains mysteriously hidden. Some speculate it's shrouded in dust, others wonder if it collapsed further into a black hole. The answer could redefine our understanding of supernova remnants. This isn't just a relic, it's a living laboratory. Every new observation peels back another layer, from the formation of molecules in the wreckage, hinting at how supernovas seed space with life's ingredients, to the behavior of neutron stars, nature's most extreme matter factories. SN 1987 reminds us that even in destruction, the universe unveils its secrets, one shockwave at a time. Now, shift your gaze from stellar fireworks to a place where stars huddle shoulder to shoulder, their numbers defying comprehension. The next cosmic wonder doesn't just dazzle, it overwhelms, packing suns so tightly they rewrite the rules of gravity itself. Omega Centauri isn't just another cluster of stars, it's a cosmic time capsule, a glittering sphere of ancient suns so densely packed that from a planet within it, the night sky would blaze with thousands of stars brighter than Venus. This globular behemoth, floating 15,000 light-years away, contains nearly 10 million stars crammed into a space just 150 light-years across. To put that in perspective, if you replaced our Sun's neighborhood with Omega Centauri's core, you'd see over 1 million stars with the naked eye, enough to cast shadows at midnight. But what makes this swarm truly extraordinary isn't just its staggering stellar population, it's the secrets buried in its heart, where an elusive cosmic predator may lurk. Deep within this stellar anthill, astronomers have detected something peculiar: stars whipping around an invisible center at speeds too fast for the cluster's visible mass to explain. The math points to one tantalizing possibility: an intermediate black hole, a rare celestial missing link with a mass thousands of times greater than our Sun. Unlike the supermassive black holes anchoring galaxies or the smaller stellar mass black holes born from collapsing stars, these mid-sized enigmas have long evaded detection. If confirmed, Omega Centauri's hidden beast could rewrite our understanding of how black holes grow, offering clues to one of cosmology's biggest puzzles: how the universe builds its gravitational monsters. Yet the cluster's mysteries don't stop there. Its stars are a living fossil record, some nearly as old as the universe itself. Their chemical makeup tells a story of multiple generations' metal-poor relics from the cosmic dawn, mixed with younger stars enriched by supernova. This unusual diversity has led scientists to suspect Omega Centauri wasn't always a cluster. Its sheer size and complex structure suggest it might be the stripped core of a dwarf galaxy, devoured by the Milky Way billions of years ago. The stars we see today could be the surviving remnant of a once proud galaxy, its outer layers shredded by tidal forces, leaving only its dense heart behind. Peer through a telescope, and Omega Centauri appears as a fuzzy patch, but zoom in, and it transforms into a snow globe of stellar fire. The cluster's core is so crowded that stars occasionally collide, creating bizarre blue stragglers, stars rejuvenated by stolen mass that glow younger and hotter than their ancient neighbors. Meanwhile, red giants pulse like embers, their swollen atmospheres bleeding into space. This dynamic environment, where stars interact in ways impossible in our sparse galactic neighborhood, offers a front-row seat to stellar sociology, how stars behave when forced into cosmic urban density. What makes this globular giant so captivating isn't just its scale or its secrets, but its accessibility. Unlike distant galaxies or faint nebulae, Omega Centauri is visible to the naked eye from the southern hemisphere, a bridge between backyard stargazing and cutting-edge astrophysics. It's a reminder that the universe's most profound wonders aren't always billions of light years away. Sometimes they're hiding in plain sight, waiting for us to look up and wonder. Now shift your gaze from this ancient stellar city to a phenomenon where space itself bends and shudders, a landscape not of matter, but of pure geometry. The next cosmic wonder doesn't just exist in space, it warps the very fabric of reality. Gravitational waves are the universe's hidden language, ripples in spacetime itself, carrying whispers of collisions so violent they shake the fabric of reality. When two black holes spiral toward each other, locked in a death spiral, they don't just crash, they warp the cosmos around them, sending out waves that travel at light speed across billions of years. The first time scientists detected these waves in 2015, it wasn't just a discovery, it was a revolution. For centuries, astronomy relied on light, but now we're listening to the universe's vibrations, tuning into events too dark, too distant, or too cataclysmic to see. The most spectacular sources of these waves are black hole mergers, where gravity's most extreme objects dance toward oblivion. Picture two voids, each dozens of times the mass of our Sun, orbiting each other hundreds of times per second in their final moments. As they merge, they release more energy in gravitational waves than all the stars in the observable universe emit as light. The resulting shockwave stretches and compresses spacetime itself, a distortion so minuscule that LIGO detectors measure shifts smaller than 1/10,000th the width of a proton. Yet that tiny tremor tells us everything: the black hole's masses, their spins, even the direction they came from. But black holes aren't the only cosmic drummers. Neutron star collisions called kilonovae are even richer events. When these ultra-dense stellar corpses collide, they don't just send out gravitational waves, they light up the cosmos in a fireworks show of gamma rays, X-rays, and visible light. The aftermath is a cosmic alchemy lab. The intense pressures and temperatures forge heavy elements like gold, platinum, and uranium, scattering them into space. That wedding ring on your finger, its gold was likely born in a neutron star collision billions of years ago. What makes these discoveries so transformative isn't just their spectacle, it's how they've opened a new window on the universe. Before LIGO, black holes were silent phantoms, detectable only by their effects on nearby stars and gas. Now we can hear them merge across cosmic distances, mapping populations we never knew existed. Some of these black holes are far heavier than expected, challenging theories about how they form. Others spin in ways that suggest they were born from previous mergers, ghosts of collisions long past. And then there's the spacetime itself. Gravitational waves don't just carry information about their sources, they test Einstein's theory of relativity with unprecedented precision. Do the waves travel at light speed as predicted? Does spacetime behave exactly as expected under such extreme strain? Every detection is a stress test for the laws of physics, probing regimes no lab experiment can replicate. Yet for all their violence, these events are strangely poetic. A black hole merger is the universe's way of erasing information, a paradox that still puzzles physicists. A neutron star collision, meanwhile, is the opposite, a creative act scattering the seeds of future planets and life. Gravitational waves remind us that the cosmos isn't just something we observe, it's something we feel. A symphony of ripples that connect us to the most distant, cataclysmic events. And with every new detection, we're not just learning about the universe, we're learning how to listen. The Great Attractor lurks in the cosmic shadows like a gravitational siren, pulling thousands of galaxies toward it with irresistible force, yet we can't even see what's doing the pulling. Hidden behind the dense star fields and dust clouds of our own Milky Way's galactic plane, this mysterious region remains one of astronomy's most tantalizing blind spots. Everything in our local universe, the Milky Way, Andromeda, and countless other galaxies is drifting toward this invisible focal point at over 2 million kilometers per hour, as if the cosmos itself is tipping toward some unfathomable destination. For decades, the nature of this phenomenon baffled scientists. How could something so massive with the gravitational pull of tens of thousands of Milky Ways remain hidden? Early theories speculated about exotic possibilities, a colossal concentration of dark matter, a supermassive black hole of unimaginable scale, or even a flaw in our understanding of gravity itself. But as observational technology advanced, glimpses through the galactic veil revealed a more complex truth. The Great Attractor isn't a single monstrous object, it's likely the heart of the Laniakea supercluster, an immense web of galaxies spanning over 500 million light-years, with the Norma cluster at its dense core. Yet the mystery deepens when you consider the numbers. Even Laniakea's combined mass can't fully account for the observed motion. There's something beyond it, an even greater gravitational influence dubbed the Shapley Attractor, pulling the Great Attractor itself across the cosmos. This revelation paints a humbling picture. Our entire supercluster is just a single leaf caught in a vast cosmic current, part of a flow pattern stretching across billions of light-years. What makes this region so fascinating isn't just its hidden mass, but how it reshapes our cosmic address. We're used to thinking of the Milky Way as the center of our celestial neighborhood, but the Great Attractor reveals we're passengers on a much grander voyage. Every galaxy in our vicinity is swept up in this motion, like twigs floating down a river toward some distant waterfall. And just as rivers have tributaries, astronomers now map these galactic flows, tracing filaments of dark matter that guide the universe's large-scale structure. The real challenge lies in observation, peering through the Milky Way's zone of avoidance. The dusty region blocking our view requires unconventional tools. Infrared and radio telescopes like Parkes and WMAP have pierced the gloom, revealing galaxy clusters and strange structures like the dark flow, where entire clusters drift in unison toward some unseen mass beyond the observable universe's edge. Each new dataset adds pieces to the puzzle, but the full picture remains elusive. Perhaps the most profound implication is this: the Great Attractor reminds us how much we still don't know about our cosmic neighborhood. In an age where we've mapped the afterglow of the Big Bang and photographed black holes, entire chapters of our local universe remain blank pages. Whatever ultimately explains this gravitational enigma, whether superclusters, dark energy asymmetries, or something entirely unforeseen, it's a testament to the universe's endless capacity to surprise us. The cosmos doesn't just hold wonders in distant quasars or ancient light. Sometimes the greatest mysteries are hiding right in our own backyard, obscured by the very galaxy we call home. Hogue's object floats in the void like a celestial bullseye, a perfect ring of young blue stars encircling a golden core of ancient suns, a galaxy so peculiar it makes astronomers question everything they know about galactic evolution. Unlike the familiar spirals or featureless ellipticals that dominate the universe, this cosmic oddity presents a pristine circle with no visible connecting structures, as if someone dropped a stone into a pond of stars and froze the ripples in time. The ring itself spans 120,000 light-years, larger than our Milky Way, yet the central core remains mysteriously detached, floating in isolation like an island inside an island. This isn't just a pretty anomaly, it's a galactic enigma that defies conventional formation theories. What makes Hogue's object so baffling isn't just its symmetry, but its contradictory ages. The central core is packed with old, reddish stars typical of ancient elliptical galaxies, while the surrounding ring blazes with the blue light of newborn stellar nurseries. Normally, such stark contrasts suggest a violent past, like a collision that sent shockwaves through gas clouds, triggering star formation in a ring. Yet there's no evidence of a second galaxy that could have caused this disruption, no debris or distortions to betray a cosmic crash. It's as if the ring simply appeared, a stellar halo suspended around its core by invisible hands. Some theories suggest a rare, peanut-shaped galactic merger billions of years ago, where the intruder galaxy was absorbed so cleanly it left no trace. Others propose a spontaneous instability in the original galaxy's disk, causing stars to reorganize into this improbable structure. Zoom in closer and the mystery deepens. The gap between the core and the ring is eerily empty, no trailing stars, no faint bridges of dust. Even more perplexing, recent observations reveal a second, fainter ring outside the first, hinting at multiple epochs of star formation. This layered structure suggests Hogue's object didn't form in a single cataclysm, but through a series of events we've yet to unravel. The galaxy's sheer isolation adds to the puzzle. Most ring galaxies live in crowded environments where collisions are common, but Hogue's object drifts alone, a cosmic hermit with a secret history. Yet for all its strangeness, this galactic oddity offers a gift, a chance to study star formation in a controlled environment. The ring's perfect circle acts like a petri dish, allowing astronomers to examine how stars are born under uniform conditions, free from the chaos of spiral arms or merging neighbors. The results challenge assumptions. Star clusters here form differently than in our Milky Way, with sizes and distributions that don't match standard models. It's a reminder that the universe often reserves its greatest lessons for the outliers, the exceptions that refuse to follow the rules. Hogue's object stands as a testament to the universe's creativity, a place where the expected gives way to the extraordinary. In its perfect rings, we see not just a mystery, but an invitation to rethink how galaxies evolve. Somewhere in the void, other ring galaxies may hide, each with its own story. For now, this one remains a celestial riddle, whispering that even in the cosmos, beauty often wears the mask of the unexplained. Now, turn your gaze to a phenomenon where light doesn't just bend, it's imprisoned. The next cosmic wonder doesn't just challenge perception. It defies the very nature of visibility, trapping photons in an endless loop where escape is impossible. Dark matter halos are the universe's silent architects, vast, invisible structures that outweigh all the stars, planets, and galaxies we can see, yet leave no trace beyond their gravitational pull. Picture a spiderweb stretching across billions of light years, its threads unseen but its grip unshakable, sculpting galaxies into spirals, guiding their motions, and binding clusters together in an intricate cosmic dance. Without these hidden scaffolds, galaxies would fly apart, their stars scattering into the void like leaves in a hurricane. Yet despite making up 85% of the universe's matter, dark matter remains one of science's greatest enigmas, a ghostly presence that refuses to reveal itself, leaving only whispers in the motions of stars and the bending of light. The evidence for dark matter is everywhere once you know where to look. Take the Whirlpool Galaxy. Its outer stars orbit so fast that, by all rights, they should be flung into space. The math doesn't add up unless there's an invisible mass anchoring them, a halo of dark matter 10 times heavier than the galaxy itself. Or consider the Bullet Cluster, where two galaxy groups collided, stripping away their gas like cosmic bumper cars. The visible matter stalled, but the gravitational lensing revealed something astonishing. The mass kept moving ahead, carried by dark matter like an unseen runner passing the baton. These aren't isolated quirks, they're clues to a hidden framework underpinning the entire universe. Scientists have chased this phantom for decades, testing theory after theory. Could dark matter be weakly interacting massive particles that barely touch ordinary matter except through gravity? Or perhaps actions, ultralight particles streaming through space like an intangible wind? Some even speculate it's evidence of extra dimensions or a flaw in Einstein's gravity itself. The hunt has led to experiments buried deep underground, where detectors wait for the rare ping of a dark matter particle, and to space telescopes mapping the cosmic web's faint distortions. So far, the mystery endures, defying every attempt to trap it. Yet the implications of solving this puzzle are staggering. Unlocking dark matter wouldn't just fill a gap in our textbooks, it could rewrite physics, revealing new forces or particles beyond the standard model. It might explain why galaxies formed so quickly after the Big Bang, or how black holes grew to impossible sizes in the universe's infancy. Some theories even suggest dark matter could harbor hidden complexities. Dark atoms, dark stars, or even dark life, entire shadow ecosystems forever beyond our perception. What makes dark matter halos so mesmerizing isn't just their invisibility, but their artistry. Simulations show them as intricate, branching networks, with galaxies perched along their filaments like dew on a spider's web. They're not static, they ripple and evolve, merging and splitting in a slow-motion ballet that shaped everything we see. And somewhere in their depths, the answer waits, a key to understanding why the universe looks the way it does, and what invisible hands molded it into being. This is the ultimate cosmic illusion, a universe where most of what exists hides in plain sight, its presence felt but never seen. As we stand on the brink of discovery, one thing is certain: the day we unravel dark matter's secrets, the cosmos will seem stranger, richer, and more mysterious than we ever imagined. The Hubble Ultra Deep Field isn't just a photograph, it's a keyhole into infinity. Imagine pointing a telescope at a patch of sky no larger than a grain of sand held at arm's length and finding it packed with over 10,000 galaxies, each a swirling island of stars, dust, and untold worlds. This iconic image, captured over weeks of exposure time, reveals cosmic history frozen in light, stretching back over 13 billion years. Some of those faint smudges are infant galaxies as they appeared just 400 million years after the Big Bang, their light only now reaching us after an unimaginable journey. What makes this cosmic core sample so revolutionary isn't just its depth, but its humility. The Hubble didn't aim for dazzling nebulae or colliding galaxies. It stared into what seemed like empty space, revealing a universe so densely packed with galaxies that even the voids between them are an illusion. Every direction we look, no matter how blank it appears, hides similar multitudes. The implications are staggering. If such abundance exists in a random sliver of sky, the observable universe could contain over 200 billion galaxies, each with hundreds of billions of stars. Our Milky Way isn't just one of many, it's a single brushstroke in a canvas that defies comprehension. Zoom in closer, and the ultra-deep field becomes a family album of galactic evolution. The youngest galaxies are small and irregular, clumpy collections of stars still finding their shape. Over billions of years, they'll collide, merge, and mature into the spirals and ellipticals we recognize today. Some show telltale signs of ancient violence, tidal tales from long-ago collisions, or the faint glow of supermassive black holes at their cores. Others are so distant their light has been stretched into infrared by the universe's expansion, requiring instruments like the James Webb Space Telescope to reveal their secrets. This isn't just a static snapshot, it's a time lapse of cosmic growth compressed into a single frame. Yet the most profound lesson lies in perspective. Every galaxy in this image, from the faintest speck to the brightest spiral, represents a potential home for life or a monument to its absence. Some may have already burned out, their stars gone dark eons before Earth formed. Others might host civilizations asking the same questions we are, gazing into their own night skies with wonder. The Hubble Ultra-Deep Field doesn't just show us the universe's past, it holds up a mirror to our own insignificance and grandeur. We're inconceivably small in this ocean of galaxies, yet we're the ones who built the telescope, decoded the light, and dared to ask what it all means. This tiny patch of sky is more than science, it's philosophy written in starlight. It whispers that the universe doesn't revolve around us, yet it also celebrates that we're here to witness it. Every photon in this image traveled billions of years to reach our eyes, making us not just observers, but participants in a story that began long before us and will continue long after. The Hubble Ultra-Deep Field isn't just a window into space. It's a mirror reflecting our endless curiosity and a reminder that the cosmos always has more to reveal to those willing to look. From the fiery chaos of stellar nurseries to the ghostly whispers of dark matter, these 22 cosmic wonders have taken us on a journey beyond the edges of human imagination. Each landscape, whether sculpted by gravity, painted by radiation, or frozen in time, holds a story that reshapes our understanding of the universe. The pillars of creation teach us about the fragile beauty of star birth, while the Crab Nebula reminds us that destruction can be just as spectacular. Einstein's cross bends reality itself, and the Great Attractor tugs at galaxies like an unseen puppeteer. These aren't just distant curiosities, they're pieces of a puzzle we're only beginning to assemble, each one revealing how small and how remarkably curious we truly are. What makes these wonders so extraordinary isn't just their scale or their science, but the way they blur the line between discovery and wonder. The universe doesn't just obey rules, it reinvents them, crafting diamonds from the crushing depths of Neptune's atmosphere and spinning galaxies into perfect rings like Hogue's object. Even the coldest corners of the Boomerang Nebula or the violent storms of Eta Carinae remind us that the cosmos thrives on extremes, constantly pushing the boundaries of what we thought possible. And yet, for all their grandeur, these landscapes are deeply personal. Every atom in your body was forged in places like these, in the hearts of stars or the aftermath of collisions that lit up the darkness billions of years ago. So as we wrap up this journey, ask yourself, which of these cosmic masterpieces left you breathless? Was it the haunting glow of the Helix Nebula, a preview of our own sun's fate? Or perhaps the gravitational waves rippling through space-time, carrying echoes of black holes colliding in the void? Whatever your answer, one thing is certain: the universe is far from done surprising us. With every new telescope, every fresh observation, we're peeling back another layer of the cosmic onion, finding more questions than answers, and that's the real magic. The cosmos isn't just a static backdrop, it's a living, evolving story, and we're lucky enough to be here to witness it. Before you go, let us know in the comments which cosmic landscape captured your imagination. Was it one of the 22 we explored, or another wonder that leaves you in awe? If you enjoyed this journey through the universe's most mind-bending sights, don't forget to subscribe and hit the notification bell so you never miss an adventure. The cosmos is vast, mysterious, and endlessly generous with its secrets. So keep looking up, stay curious, and remember, somewhere out there, the next great discovery is waiting, and it might just change how we see everything. Until next time, fellow stargazers, the universe has plenty more to show